Hello friends. So once again welcome you to my channel. In this video we will start performing the IO operation. In the last video we have seen the methods of performing the IO, methods of assigning addresses to the IO devices. Basically two categories were there, memory mapped IO and IO mapped IO. Then now we know how to recognize our device. Next we will perform or we will talk to the device. So next I'm starting with the methods of performing the IO operations. So there are three modes of IO transfer is there: program controlled IO, interrupt driven IO, and the last one is DMA. So in this chapter basically we will see all the three methods. So first I will start with program controlled IO. So see, in case of program controlled IO, what we are going to do is we will perform one either input or output operation. Let's say we'll take the example of input operation. So what we know that our devices are inherently slower compared to the processor, right? So see, whenever we need to read something from the keyboard, we should read only when there is a valid keystroke in the keyboard. Whenever there is a valid keystroke corresponding to it, whatever code is there, ASCII code is there, that will be there in the buffer register attached to the keyboard. Say the name of that buffer register is data in, right? And with the keyboard in the interface, one status word or status register is there. The status register various bits indicates various conditions for after performing an operation. Here basically we'll be interested to know whether there is a valid keystroke or not. Whenever we press a key, valid keystroke will be there. Then automatically this zeroth position bit will become automatically 1. Whenever we press a key, that time the S in this particular bit position will become 1. S in for status of your input operation. So whenever there is a valid keystroke, S in will become 1, right? So when should we read the data from the data in register? We means what? Processor should take the information from the buffer register only when the status words the last bit is 1. And once we take the data, we have performed the read operation, then that operation will automatically will clear this flag. So see, looking at this flag, we should perform the operation. Once the operation is performed, the flag will be automatically cleared to 0, right? So this we need to do, right? So see what processor will do. Processor will repeatedly monitors a status flag to achieve the necessary synchronization. What synchronization it is trying to do? It is trying to read only when there is a valid keystroke. What is processor's capacity? We will not see. But whenever there is a keystroke, then only processor should read, and it should not read the same data taking to assuming it as separate keystrokes. So once one particular data is read, automatically the flag register will this particular bit will become automatically 0. So what processor will do before performing a read operation? From where it will read? From the buffer register that data in, right? Then it will perform the read operation only when this bit position is 1. And if it is not 0, it will keep on checking it whether it is 1, whether it is 1. Once it will find it 1, then it will read the data. Once it will read the data, then what will happen? This will automatically becomes 0. So that we are trying to achieve. And so what we are telling, the method name is program controlled IO. So here what we will do, whatever I said that SN is 0, I will not read, SN is 1, we will read, and then it will be cleared to 0. So whatever I have said, to achieve that we will write a set of instructions, and the set of instruction is called as a program. So by executing this program repeatedly, we are going to achieve the required synchronization between the CPU and the IO device. Because of that, the name of the method is program controlled IO. Program is controlling the IO operation. So now we will see it at better details. So processor polls the IO device. Pause the IO device means it will keep on checking whether are you ready? Are you ready? That means what? This bit is 1. If it is so, then only data in register will be read. So one data in register, one status register is there in the interface of the IO device, right? Here the actual keystroke will come. Here it will tell me whether it is a valid keystroke or not. So this part is clear. Now we'll perform the IO operation using this method only. We have taken one simple example. What we'll try to do, we'll read a line from a keyboard. So we will type something, suppose India, India, India is my country. India is my country. I will type that, and then after that I'll press the enter line. So see, enter character. So reading a line from keyboard. So it will see whatever I am going to do, that will allow me to keep on typing the characters until I press the enter key. So what it will do, reading a line from keyboard, it will do that character wise and store it in memory location starting from line. So in memory, I am going to store whatever I have typed. So first it will store I, then N, then D, then I, then A, and it will keep on storing each character that I have typed in the memory location starting from line. The line is representing 1000. So from memory location 1000, it is going to store whatever keystrokes we have given. And when it will stop, it will do the operation repeatedly, but it will stop reading process once the enter key is pressed. And then it will do subsequent operation. Say the subsequent operation is calling another function that will process the taken input. Maybe it will perform some operation, right? We are not interested in that. Right now, our main concern is to read the line. So see, we will read the line. How we are going to read? Character wise. When I will read the character? When the SIN is 1. If SIN is 0, whether I am going to read? No. What I am going to do? Again, I will check the SIN. I'll keep on checking the SIN until it becomes 1. Once it becomes 1, I'll take the keystroke and I will store in the memory location line. This I am going to do until I press the new line character. So for that, we'll see the program. So see, move hash line comma R0. That means what? Suppose this line is representing some number. It is representing 1000. So R0 is holding what? 1000. Means I am giving the starting address of my memory location where I am going to store the characters into register R0. This part is clear. Then next is, this is a very important line. In the status register, the bit position number 0 is the indicator of whether there is a valid keystroke or not. So if this position is 1, it is a keystroke. And if it is 0, that means valid keystroke is not there. So I need to check that. How to do that? I cannot refer to the individual bit of this register in my instruction. So for that, for helping this part, there is one instruction. Hope you remember test bit. When we have discussed the instruction set, some special instruction we have seen. There we have seen test, compare instructions and all. What is the job of test instruction? What it will do? This instruction will perform, what it will do, it will perform one AND operation with the content of your SIN register, right? Sorry, with the content of status register. So status register, here some bits are carrying some values. I don't know their values, so I am representing as don't care. And this position may be 1 or maybe 0. What I will do, I will AND it with all 0. I will AND it with all 0, and this position I will AND with 1. This instruction will do that automatically. And after doing the operation, if every bit, these bits will become 0, ending with 0 is 0. But if it was 1 here, it will become 1. Result will become 1. But if it was 0 here, the result will become 0. So what this instruction will do, it will perform this operation, this AND operation it will perform with this operand, with the operand status register, right? Which position it will check for 1? Bit position number 0, that is part of the instruction. So we will check SIN flag at position 0 by ending with 1, all other bits by ending with 0. And if the result is 0, that means what? Result is 0 means what? This flag is still 0. If it is 0, Should I take the character? No. I again need to check it. So again my control is going to what? Wait k, means wait for one keystroke. I'm giving one meaningful name to my level. So again I will go to this. When I'll go to this, when branch equal to 0. What does it mean? It will check the result of previous instruction. It will check the result of this instruction. And this instruction result, if all the bits are 0, then I will be again going to this. Do remember, this is non-destructive AND operation. What does it mean? My this register is not getting affected. Only it is used for performing the AND operation. This much is done. I'm getting result 0, so I'll be waiting. But suppose the result is not 0. So this condition will not be satisfied. If the condition is not satisfied, where will I go? I'll go to the next instruction in sequence. So my next instruction should be what? Take the data from here to register R1. I'm taking to some register R1. So see here I have used move. That means what I am using? Memory mapped IO. Because to talk to my IO device, I am using the same instruction as that of memory. So I am using memory mapped IO. So from data in register, I have transferred the content into register R1. Now where at all I need to take it? To memory location pointed by R0. So what I will write? Move R1 comma R0 plus move R1. This content of R1 is what? The keystroke. Suppose I have typed India. So ASCII code of I is there here. That is transferred to the memory location pointed by R0. And then R0 will be incremented to point to the next location. So suppose initially it was at 1000. So I will be stored there. ASCII code of I will be stored there. Then R0 will become what? 1001. Right? So read character is whatever we have read, that character is moved to memory location pointed by R0. So I is now stored here because they have told us to store it in a memory location starting with line. We did this. After this, what I have to do? I have to see whatever we have typed, whether that is a new line character, enter key. Enter key's ASCII code is 13. In hexadecimal, we can write 0D. So I need to see whether whatever is there in R1, that is the ASCII code of I right now, whether that is equal to the means $D. Dollar is for your hexadecimal, hash is for immediate operand. 0D, that means 13. So I am comparing the content of R1 with 13. How do I compare? By performing a non-destructive subtraction operation. So if the result of subtraction is all 0, what does it mean? R1 is containing that enter key. Then only both the ASCII codes will be same. So subtraction will be 0. If it is not 0, that means I have not pressed the enter key. So let's read the next character, right? So see here, branch not equal to 0. If it is not equal to 0, the compare result is not equal to 0, means both are not same. Then what should I do? I should read the next character. To read the next character, I should wait till I press the keystroke. So I need to see whether there is a keystroke. Again, I will check the status register last bit, that is LSB bit, least significant bit. If it is 0, I have to wait. If it is 1, I will perform the operation. So see, branch not equal to 0, then only go here. If it is 0, that means what? Your reading character is over, right? So if your this type character is new line, then we need to stop because our stopping condition is till you press the enter key. So once it is enter key is pressed, we will stop. So after that, we are calling a function, that is process1, to do the next set of processing. So basically here see, this part is achieving the synchronization. This part is for what? Stopping the input operation, right? So here see, this part is achieving the synchronization. This part is doing what? My stopping condition. Here I am actually reading the data. So hope all these parts are clear to you. And to perform this IO operation, we are executing one set of instruction, that is nothing but a program. Hence the name is program controlled IO. Hope you have understood what is program controlled IO. So if you are getting from my explanations, so then please do not forget to like my videos and subscribe to my channel. In my next video, I am going to discuss the next method of IO. Till then, thank you.